By 2030, integrating artificial intelligence into Northern Ireland's economy is projected to generate an additional £1.2 billion in gross value added. That projection relies on highly specific functional upgrades across the public sector. We're looking at predictive models directing preventative road maintenance and generative AI systems acting as personalized tutors for students in regional schools. But there is a hard bottleneck stalling this rollout. The public does not trust the technology. Recent polling shows that 75% of citizens do not trust AI to be used ethically. Even worse for public deployment, only 10% trust the government to manage it appropriately. If a population actively resists adoption, the technical capability of the software is irrelevant. You cannot force a disruptive technology onto a distrustful public. The default way governments tend to adopt AI is deeply flawed. Different departments run ad hoc, isolated experiments without shared standards or centralized safeguards. Northern Ireland's 2026 Artificial Intelligence Strategy aims to solve that exact problem. The document outlines a shift in how the state handles technology. It moves away from debating abstract ethical philosophy and establishes hard, operational standards for public procurement. To enforce accountability, the region is deploying a strict 8-principle framework that every public sector project must adhere to. The only way to successfully deploy AI in government is to translate ethical desires into an enforceable engineering checklist. Before a government can regulate AI, policymakers have to define what they are actually regulating in a way that works legally and operationally. Defining AI by its internal architecture, like neural networks or large language models, is a mistake. The code evolves too fast, and the technical jargon makes policy brittle and difficult to enforce. The Northern Ireland strategy solves this by classifying AI systems strictly by their functional outputs. They group the technology by what it actually produces. The first category is predictive AI. This analyzes massive data sets to forecast future outcomes, like predicting hospital bed shortages or detecting fraudulent financial transactions. Next is generative AI. These are systems built to create novel content, text, images, or synthetic data, often used to draft reports or simulate molecular structures for drug delivery. Finally, autonomous AI. These systems operate independently to complete complex, multi-step tasks, such as directing smart traffic grids or managing automated drone fleets. By focusing on outputs, policymakers can accurately assess and mitigate the real-world impact of a system, rather than getting bogged down in how the code is written. Once defined, every AI system is subjected to a central framework built on 8 distinct principles. These pillars operate across 3 specific categories: operational standards, ethical requirements, and enabling structures. These are not passive values. They are mandatory operational expectations that dictate exactly how AI must be procured and managed. Take Principle 1, human oversight. A public sector organization cannot simply buy an algorithm and let it run. They must assemble a formal human oversight team. This team has a legal obligation to document precise intervention points across the entire lifecycle of the AI, proving exactly where and how a human will override the system if it makes a mistake. Or consider Principle 3, data governance. Before a single model is trained on citizen data, departments are required to clear a data protection impact assessment.
The data flow is entirely halted until privacy is secured. This framework injects deliberate legal friction into the engineering process. It forces accountability long before any software interacts with the public. Setting standards is one thing. Actually auditing compliance across hundreds of external software vendors is a massive logistical challenge. To solve this, the region utilizes the Core Assessment of Governance and Ethics, or CAGE tool. Evaluators input parameters regarding risk and data usage. The tool maps these inputs across 6 axes, generating a geometric shape and a quantified score. In this case, a 56 out of 251 indicates a highly ethical baseline. Running this audit generates strict required outputs, a quantifiable harm assessment, and a comprehensive data fact sheet detailing exactly what feeds the model. This governance bundle becomes the barrier to entry. If external suppliers want to secure lucrative public contracts, their software must meet these exact scores.
By making ethics mathematically auditable, governments can bridge the gap between demanding safety and actually executing procurement. Let's apply this framework directly to a public sector use case outlined in the strategy's transformation targets. Consider the deployment of an autonomous AI system designed to detect abnormal flows and toxic contamination in municipal wastewater management. If you deploy that system blindly, a false positive could trigger automated resource misallocation, shutting down the wrong pipelines and causing a public health crisis and immediate citizen backlash. Applying Principle 4, technical safety, forces engineers to prove the system is cyber resilient against external tampering before it is ever connected to the municipal grid. Next, Principle 6, sustainability, demands that planners calculate the intense compute energy required to run the AI and weigh it directly against the environmental savings of preventing a toxic spillover. Firmly applied governance neutralizes the catastrophic operational risks of autonomous systems, allowing the state to safely extract their massive utility. A policy document cannot run on its own. It requires a physical and educational foundation to actually function. First is the hardware. Because cloud services are too expensive for deep research and present data privacy risks, the region requires sovereign, high-performance compute infrastructure, specifically green data centers powered by excess renewable energy. Second is human capital. Without dedicated upskilling hubs and public sector skills academies, a lack of AI literacy will become a fatal deployment bottleneck. The strategy maps this out as a quadruple helix model, a required alignment where government, industry, academia, and private citizens work in tandem. An ethical governance framework without localized compute infrastructure and a trained workforce is nothing more than an unfunded mandate. We return to the central paradox, capturing a £1.2 billion economic opportunity while navigating overwhelming public distrust. The tension is resolved by marrying sustainable, localized computing power with a strict 8-pillar operational framework. By utilizing auditing tools like CAGE, the state forces transparency. It transitions AI from an untrusted, opaque black box into a measurable, regulated public utility. In the modern era, regional governments do not succeed by trying to build the smartest algorithms. They succeed by architecting the most trustworthy and auditable frameworks to deploy them.